Hi guys, welcome to the computer science problem solving second lecture. So last week we went through algorithms, understanding algorithms, and we jumped into some parts of bubble sorting, and we went through a little bit into an algorithm. Okay, so today what we are going to do is we will be jumping in deep and go through the rest of the algorithms. Hi, yeah, good morning. So before we start, now I want you guys to take down few points. Okay, so in your exam, you do get questions asking what is an algorithm and what is pseudocode. Okay, so those 2 points are very important, and I will share the workbook in the chat as well, so you guys can actually go through the first part of the workbook where it has some questions, and we will do that at the end of this lecture, so that we will complete the workbook and you will have a full complete note about what we did so far. Okay, so just to take a quick note in, you have to so please write this down. So the primary question we get is always what we get is what is an algorithm. Okay, so an algorithm is basically a precise method for solving a problem. Okay, an algorithm is a precise method for solving a problem. So as we went through algorithms, you guys, if you have missed the previous lectures, you can check my YouTube channel or you can get the links in the LMS. So we talked about a couple of different algorithms, and we talked about this example in the book where it actually creates, or which we make a cup of coffee. Okay, so there's a flow, we make a cup of coffee, we get few items in, we boil water, and so on and so forth. So it's basically the flow, right? So yes, so the topic is what is an algorithm, and the point you have to write down is this one. Okay, so if you need more time to do this, you can obviously go through this video again. You can pause it, and all the students who are going through this video, please do the same thing as well. Okay, so hold on. Yeah, so the point is what is an algorithm, and an algorithm is a precise method for solving a problem. Then also, an algorithms can be displayed as written descriptions, flowcharts, and in pseudocode. Okay, so you have to highlight or write this down as well. So when somebody asks you what is an algorithm, make sure that you say it's a precise method, but at the same time, it to give a complete answer, right? You have to make sure that you mention this part as well. Okay, so and then so that's about algorithms. Then you get another question asking what is pseudocode. Okay, so that's a pretty simple answered question. So pseudocode, we went through the pseudocode syntax during one of our previous classes. So pseudocode is mainly a structured code-like language. Okay, so pseudocode is a structured code-like language. So why do we need pseudocode? We use pseudocode to translate whatever the algorithm which we have written into program code. Okay, so pseudocode is translated into program code. Since pseudocode is comprised of this algorithm which we have made, that's going to be converted into program code. Okay, so in okay, so those two are the primary points you have to write down: what is an algorithm and what is pseudocode. Be careful, that's a common question which you get on almost all the papers, which will go until your advanced levels if you do IAL as well. So be careful, keep that in mind. Okay, perfect. Hope that is clear, and let's jump back to where we stopped last week. So just to do a recap of what we went through, we basically went through the sorting and searching algorithms. Okay, so sorting and searching algorithms, why we need this. So whenever we want to find some information, okay, it can be any information. It can be something to do on a search, or it can be something to go through a a certain set of numbers. Or as you can see in this example, so just imagine the number of people around the world who are using the same, like something like a same search engine, right? So this is basically the same concept where you will be following to make sure that you have an efficient searching algorithm. Okay, so in simple terms, again, I'll try to simplify this again. So searching is, now when we have a set of items, there has to be a certain way of searching through it, right? So searching is not that simple, right? So there can be multiple different types of requirements. So let's say if you get a number of, let's say you get the number of students in a class and the marks they received for their exams. Okay, so then let's say you're building a software for your classroom, and in that classroom the class teacher asks you to sort all the students according to the order of starting from the lowest, the person who got the lowest marks to the highest marks. Okay, now that's a big task. Let's say if you have 100 students in a classroom, okay, so that means you must sort this in a particular order so that the classroom, the data set or that particular data column will have the data sorted, right? So for that we use sorting algorithms. Okay, so sorting algorithms, there are different points which we use them. So example is, now you can see this is something which I explained earlier about the vocabulary block. Okay, so vocabulary is the terms which you need to remember when it comes to different points in the system, right? So in this case we have two vocabularies, vocabularies. So in this case we have the ascending order, descending order, and also there's a point called traversal. Okay, so ascending order, obviously it's 1 to 3, and if it is descending order, then it's from the largest number to the lowest number, right? Ascending lowest to the highest, highest to the lowest. And traversing means we travel across something. So let's say we traverse from one point to the other. That means we are traveling from one location to another location. Okay, so remember these keywords. These keywords are being used almost everywhere in the in this particular sorting module. So last week we went through bubble sort. So we went through how it works. So bubble sort is the most common sorting algorithm, and guys, be careful. We will do that at a later time. But you do get questions where how it asks you how this sorting can be done and how to give examples on how to write a script to make sure that the sorting is properly done. Okay, so sorting and searching based on bubble sort. So bubble sort is basically ordering something in the ascending order. Okay, so ascending order means from the smallest to the largest, right? Okay, so we went through this last week, but I'll quickly skim through so that you will get just a quick reminder about what we did. So what is bubble sort? Bubble sort is basically checking if one is greater than the other, right? So if you get check this example, you can actually see now the reason which this is known as bubble sorting is, like, if you look carefully. Okay, so when you pour some water into a glass cup, okay, you can see carefully that the largest items in the cup of water will gradually move up. Okay, so that means after, so when the water is initially poured in, automatically, slowly the largest numbers will come up, and there will be at a certain point, everything will be properly aligned, right? So in this case, we call it passes. Okay, so every pass, it will check whether the number is, let's say, number is compared, and it will make sure that goes up. So this algorithm is, let's say, is being used for multiple different purposes, as well as this is not the highest and the perfect efficient algorithm, but it actually works. Okay, so let's see, just quick to go through this how it works. So yeah, we have couples. So let's say this is the data set. So you can see we have 4, 2, 6, 1 and 3. Okay, now that means altogether we have 5 elements, right? So these are the 5 numbers, and ultimately what we need is 1, 2, 3, 1, 2, 3, 4 and 6, right? That's the ideal order we need this to be sorted, right? So how bubble sort works is, it will go through the number of elements, okay, number of elements, which will literally loop through 5 times, okay, and check if this is correct. So how does it work? So the first pass, we will check if one value is greater than the other value, and it will swap the pairs. That's it. Bubble sort, what it does is, it basically checks the other value, whether it's greater than or less than, then it swaps the value. So here it checks 4 and 2. So this is the initial data set now. So we check if 4 is greater than 2. Yes, obviously. So that means the possession is switched. Then we check 6. So then that is done, right? Then we jump into the next step, where we check 4 is greater than 6. That's not true. 4 is less than 6, right? So that means we jump to the next available character. So the next available character is 6, right? So 6 is obviously greater than 1. So that means that will switch. So 6 will basically go down, and 1 will come to the next position. So these two are switched. Then we go to the next step, where again we check if 6 is greater than 3. Yes, obviously, yes, true. So that means we switch that position. Now here one particular pass is done, right? So you can see how the number of events, so 1, 2, 3 and 4, right? So now that particular pass is done. Now we go to the next one. Okay, so the next one is, now since these two have been swapped, right? So that was swapped by this partner. So now we check the next round. So again we check. So the 2 is the lesser number. So then we check 4 and 1. Again 4 is greater than 1. So that means this is going to be swapped. And the change applies here. Then 4 is again checked with 3. So again 4 is greater than 3. Another swap. And then done. Because now 6 is at the end. So that means we don't have to check anything, because 6 is the greatest. Now here, now the 4 is also added. Now that pass is done. Likewise, then we go to the next one, and here again we check. Now since this 1 came here, that means we again have to check. So 2 is greater than 1. Obviously that is going to be swapped, and the rest is all sorted now. Right? So that's how the bubble sort works. So now this is where the tricky part comes in. So you do have to write this as an algorithm. Okay, so when you're writing this as an algorithm, now first of all you need to understand how. So when I explain it, I'm pretty sure you should have understood the flow, how how it can be done, right? But here, now you can see, who is this one? Okay, is that a avatar? Hello, Dahab. Is it a virtual avatar? This is the first time I saw something like that. Yeah, okay. Hold on, I'll just open up the chat. Yeah, no problem, no problem. Okay, that's good. Okay, perfect. So jumping back to the structure. So you do get the this thing. I'm not sure I can hear you. You're on mute. Uh, yeah, my sound is up. Okay, I think something wrong, something to do with your microphone then. Okay, check it and see. Anyway, we'll go through. So if you have any questions, please do ask. Please do interrupt. You can interrupt me anytime and let me know so that I can take you through. Okay. So yes. So now the previous method which I said, the switching part, right? So when you look at it, it's actually quite straightforward. It's just checking the next value, whether it's large, and switch it. So now this is where the tricky part comes in, because you have to write down an algorithm in a flow chart. Okay, so we discussed about flow chart during one of our previous classes. So in the flow chart, we do have this is the start, and we do have actions, and we do have conditions, and again we have actions, and at the end, if all the conditions are done, the code will end, right? So simply based on this point, you can see now here this is how the algorithm is going to start. Okay, so pay attention to this, because you guys you do get questions in the paper where they will basically ask you to write down this particular structure. Okay, so let's start. So we start the process, right? So what we check is, first of all we get the length, right? We get the length of the array. Okay, hold on. Nice, now it's much clearer. Okay, so what we do is we get the length. Here, after starting, first we check the length of the items. Okay, so if the length of the items of the list, we get it allocated into a variable, right? So after getting the length, then we get the position. Okay, so what is the position? Position means, so the starting point. So obviously the starting point should be from 1, right? And then we also keep another variable to switch. Switch means, because that has to be switched from one variable to the other. So we keep the second variable as switch. Okay, then how it works is, now you jump into this particular list. So here we have a condition. Now in this condition, now we check if the list item, which is basically the position, okay, position is greater than the list item position plus 1. See, the position we got it as 1, so that means that's the current position. That means starting from position number 1. Then we check, when we say plus 1, that means that is position plus 1. That means the next position, right? Got it? Okay. So now that means what we check is, if the list item position is greater than the next item position, then if it is yes, then we go into the swapping action. So here we swap the position. So what we take is, we get the list item position, the current position. So in this case, this is 1. right? And we get the second position, which is going to be the position +1, and we switch. Okay, so here switch means we keep the switch as +1. So that means the first value will be switched with another one. So that means the position will be added to the next position, right? So once this is switched, then again, then we go down, right? So when we go down, then we check if the position is equals to the position +1. ඇයි මෙතන අපි position එක switch වුණානේ. So we basically change the position, right? So since the position is equals to position +1, the new position, then we check if the position is equals to the length of the items. So we had 10 items. We check if it is the length. If the length is, if this is equals to the length, then you go down. Or sorry, yeah, if this is equals to the length, then what happens is you go down, and if you check if the position is switch is 0. Switch is 0 means make a switch velada කියන එක, right? Then make a switch වෙලා නැත්තම්. So if this is not switched, then now let's say, so if we go back to our example, here in the first example, this one, this got switched, so we got 4 and 2, right? So since we got 4 and 2, 4 is greater than 2, that means this has to be switched, right? So that means according to this one, position 1 is 4 and position +1 is 2, right? So obviously 4 is greater than 2, yes. So you go here, so you basically swap list item position and list item position 1, right? You basically swap the value. Here, this is where you swap it. And then you keep a variable as that you have switched. මොකද නැත්තම් switch උනාද කියලා හොයාගන්න විදිහක් නැහැ නේ අපිට. Values දෙක change වුණාට කියලා. හරි. So we keep a value as switched. And then we continue it. And at this point, we check if the position එක change වෙලාද කියලා. දැන් මෙතන position එක අපි change කරන්නේ. So we change the initial position of the first 4 into 2, right? So that means now these two have been changed, right? Changed means now the position is actually something which is equals to position +1. Value change. So then you automatically check if the position length. Change value. So if it is if the position doesn't have not changed, then automatically it goes up. The upper condition, since the position has changed, then it goes down, and then we check if the switch is 1. Then since we did the switch, we set the switch as 1, then automatically what happens is you go up. Right? So that's how this loop keeps on working. So as long as this entire process is not haven't switched anything, මොනක්වත්ම value එකක් switch වෙලා නැත්තම්, as long as no values have been switched, then it's perfectly fine. That's going to stay as it is. Okay, that's how this loop works. Okay, so we'll do something like this. Okay, so let's we'll do some activities later on. So I will show you guys how this can be coded using Python, and we'll see how it works. So for the moment, let's jump to the rest of the items and we'll see what this is. Okay, then we jump into the merge sort. So what earlier we discussed was bubble sort. Bubble sorting means, just keep this in mind, bubble sort can swap karna, as long as the items are there, we swap it, right? Then we get into merge sort. So merge sort, again we have a specific keyword. So we have two vocabulary items to learn. Okay, so please if you have a printed book, you can actually highlight this stuff. So because when we start working on the workbook, which I can show you guys. So we will be actually doing this part. So I'm not going to do this right now, but workbook here. So this is the workbook. So we will be doing this after this particular module is done. So see, we have this typical question called what is an algorithm, right? So these are the points, and you get these type of questions. An algorithm can be written. So the point I just ask you guys to write at the beginning of this class, okay? And then see algorithm, what is meant by pseudocode. And here you do get a algorithm to write converting a 8-bit number into a binary number. So we will learn this. So once we finish that part, then we will be jumping into these questions. Okay, so keep that in mind. So the flow we are going is very important for you to understand the rest of the coming modules, so that you can answer the questions properly. Okay, so so just for the vocabulary, so highlight these points. So here you have 2 points. One is the general vocabulary, which talks about the word called repeatedly. Okay, what is repeatedly? That means basically going through the same items many times. Okay, so repeatedly means many times, multiple times. And then at the same time, don't get this mixed up. We have this another term, which is basically a subject vocabulary, which is directly related to this particular subject, which is known as recursion. Okay, recursion. You write it as R-E-S-U-R. C-U-R-S-I-O-N. Recursion. Okay, so recursion is the process that is repeated. That is basically is a process which is getting repeated. So for example, a document can be checked and edited recursively until it's perfect. So let's say when you're checking your paper after writing all the answers, you have to recursively, so you have to go through a recursion, checking all the answers and to find out if everything is properly written or everything is intact. Yeah, right? Okay, so now since we know these terms, let's jump into the merge sort and see what this is. So merge sort is a sorting algorithm that divides the lists into, let's say, smaller lists. Okay, now in the bubble sort we got the entire list and we went through the list one by one. But here what we do is we split it into small components, and then we divide these components until the size of list is 1. So basically we take a big list and we divide it into multiple components until we have one item. Okay, so we do this repeatedly, applying the same method recursively, or application of the method. So we basically go through it recursively, right? So this particular method is called recursion. So in computing, these type of platforms are actually these type of verifications and validations are done almost every time. Okay, so because like when you get huge data sets, that is practically required to do sorting and so on and so forth. Maybe sorting it goes on multiple ways. Like it's being used on multiple locations, right? Like when it comes to sound, when it comes to video, like data, AI and all these things. So they do have these core concepts running behind the scenes. Okay, so let's go through an example and see. So this example is an example of merge sort, which will sort the following items into the ascending order. Okay, so let's see, let's take a look at this thing, and we can find out how it works. So this is the data set. We have 8, 4, 2, 6, 1, 3, 5, 7, right? So this is the particular data set we have. Okay, just think that these are some numbers which you are given to, okay, and you have this number set. Okay, then what you do is, this list, first of all, the list has to be split into specific points in order for you to read it at a certain level. Okay, so what you do is, this particular list, you basically split it into half and produce two particular parts. Okay, so here what we do is, we split this. So we have 8, 4, 2, 6 and 1, 3, 5, 7. Okay, so we split it into two parts, and then that would be created. So yeah, so then that is created, and then you can actually again, now as we know this particular sorting algorithm, what we do is, we keep on splitting or merging it into, splitting it into multiple parts until it's a single element, right? So here, now again here, so this is split like this, and then again, since this has two items in it, no, so what you do is, you split it again. Okay, so this continues until only one item is there in each list. Okay, so therefore each list is sorted into the specific order. Now here, now since we have only one item, now we can actually check and sort this left and right lists on how they are merged through going through a recursion. Okay, so let's see how it works. So we basically get this part done, and then now we check for these validations. Okay, so here 8 is obviously greater than 4, so we get this thing mapped. So now we have a 4 and 8, and then we have 6, 2 and 6. So since 2 and 6 is 2 is less than 6, obviously this does not change. And here again 1 and 3, yes, that's also not going to change. And again 5 and 7, yes, that is also 5 is less than 7, so that also does not change. So this will basically left again will give you the rest of the items, which you again have to split and search. So the leftmost item in each list are the lowest item of the items in those lists, right? Because see, now since this was swapped back and forth, you can see this has created a specific order and this has created a specific order, which, if you notice, everything is in the ascending order now. See, so every item is now back into the ascending order. Now again we run the same recursion. So now when we split it into two parts, you can see one part is in exact ascending order, the other one is again in the exact ascending order, and you simply merge both together. So when you merge it, again you will be again splitting things up, and it would finally merge all these two lists into a single array, so that you have one sorted list. Okay, so it's a bit tricky, but that's how it works. Okay, so compared to bubble sort, this is a bit complicated, a bit complex, I might say, because bubble sort is almost straightforward, but here it actually gets into a specific point, so that you get the items like you merge it in different methods. So now in the exam, you will be expected to show the particular intermediate stages. Okay, so now here we are only talking about 3 or 4 more stages, no? But in the exam, actually, you will have to basically write down all the stages. So we will do that once we jump into the workbook. Okay, perfect. Okay, now this is where the important point comes into action about the efficiency of sorting algorithms. Okay, so see, now this is, here you can see this x and y axis. Here you can see the total time which is required to process this particular list of items. Okay, and here you can see the number of items. Okay, so see the difference. Now depending on the number of items, automatically if you take the sorting algorithm, now if you take merge sort, depending on the number of items, the time is almost in a linear manner, right? There's a slight increase in time, but mostly the algorithm is efficient. But in bubble sort, what happens is, since bubble sort automatically goes recursively through all the items. So let's say if you have let's say 100,000 items, then bubble sort will literally loop 100,000 times. ලක්ෂ පාරක් අර සෙට් එක ඇතුලේ කැරකෙනවා. මොකද what it does is it checks one by one. ඔයා මට වඩා ලොකුද? හරි swap. ඔයා ලොකුද? නැහැ. හරි කවන්න. ඊළඟට ගියා. මෙයා ලොකුයි. හරි swap. හරි. So likewise, it goes through a massive lot of combinations and validations in order to just to validate that simple part, right? So as long as when you have huge list of items, it's going to take a long time. But merge sort, it's different. If we have 100,000 items and merge sort, what it will do is it will take the 100,000 items divided by half, left and right, 50,000, 50,000. I kadana 25,000, 25,000. I kadana 12,500, 12,500. Likewise, you split it up into multiple points, sort it, and merge. Right? Got the idea? So even if you have multiple, like couple of million items, still the number of seconds means the processing power which is going to require to process this is drastically low, right? So depending on the system, you will have to understand what type of depending on the problem, you will have to find out what type of a algorithm you are going to use. Okay, so is it clear? Daha, all good. Any questions? I think. No. Okay. Now I can hear. Okay.
Sorry, sir, my mic volume was down.
Yeah. Okay. So, I hope you have done this before as well.
Sir, in the school, sir, we did not do that.
Okay. What did you do?
Sir, we did the algorithm.
Mm-hmm.
And the one that sir is teaching right now, the effect of sorting algorithms, we did not do.
You are following the same book, right?
Yes, sir.
How come you didn't do this? Like you literally skipped this part, or?
Like we did according to our syllabus.
According to
School syllabus.
Ask the school syllabus.
Yes.
Okay, where do you school, by the way?
My school is the Lyceum International School under.
Lyceum Anuradhapura. Okay. Are they following a different syllabus? I thought this is the same book.
The same books, but I like the syllabus like changes every like year when the grade changes.
Yeah.
So like we are at like computers like the fourth unit.
Okay. You're in the fourth unit now. Okay.
Yes.
Okay. So yeah, you are following computer science, right? Not ICT, no?
Computer science.
Computer science. Hari. Ma'am, I'm still a bit confused now. So now this is the latest. I mean, what I have is the latest book for the computer science syllabus. So are you following a different book at school?
No, sir, the same book.
Hari, may part එක තියෙනවනේ පොතේ නේද?
Yes.
Okay, but okay. But you do get questions and workbook. Inside the workbook also there are questions from this particular part. I wonder why they skipped it. Okay, you should actually check.
Okay.
If there's a specific reason. Anyway, that's up to the school. That's okay, no problem. Okay, so just keep in mind. So the efficiency is really important. And okay, so just forget about school and forget about IGCSE and all these things. But like if you are building a real world application, then of course yes, this is one of the most important things you have to follow, because sorting is really a pain when it comes to CPU usage. So if you don't select the correct algorithm, you're going to get into a big trouble, because it's going to slow things down. So there are two words in this. So we call bubble sort brute force, and we call merge sort divide and conquer. So brute force, we call it brute force because it basically starts from the beginning and it keeps on fighting until the end. So it keeps on swapping, and it goes through multiple items. But merge sort is something different. Merge sort shape pege kadala. So they divide and sort, divide and sort, divide and sort, divide and sort, and then they merge everything together. So that will basically increase the number of items. Okay, so jumping into linear search. So yeah, and Raham, so I will be just going through this a little bit faster so that I can get this aligned with your everybody's school syllabus for the moment. I think everyone is almost in their second and third units. So we'll go through this as fast as possible, and then once we reach that, then we can slow down a little bit. So I hope that's okay. Yeah, perfect. So yeah, linear search. So linear search is a very simple algorithm, and it's not that sophisticated, and it simply starts at the nothing much. It starts at the beginning and goes through it item by item until it finds what it's looking for, and it is reached the end. Okay, so linear search is basically what we do is we start from the first item in a list, and we compare the item with the search item. So basically, if you have a search, now this is about searching. So previously we were talking about sorting, now we are talking about searching. So searching is quite simple. Linear search method, what you do is, let's say you have a list of items and you want to search for, let's say you have 100 values starting from 0 to 100, starting from 1 to 100, and you want to search where 59 is or 49 is. Okay, so then what happens is, linear search is quite straightforward. It just creates a loop, iteration at them, it checks one by one, trying to find where that item is. So if the item is, when it reaches that item, then it will stop the loop and it will show the position of that item or return the position of that item, so you get to know where it is. So it's a straightforward process. It just loops through the whole system and it gives you the result, right? So linear search, we don't actually use it unless if there's a specific reason, because as you know, if you have 100 and if you have 1 million items, that means this guy is going to go through each item and to check uh, whether that item is what you are looking for. So that's about linear search. And about binary search is something different, where it's basically like similar to merge sort. The binary search uses a similar divide and conquer method. Okay, so what it does is it will find the median item of the list. Okay, now we jump into another vocabulary item which is known as the median. Okay, so median සිංහලෙන් කියනවා නම් මැද මධ්‍යම කියන එක. So මැද තියෙන එක. So median is the middle number when the numbers are put according to a specific order. Okay, ascending or descending order. So example is, if there are 13 numbers, 7th number is the median, because this is an uneven set of numbers. So if if there's some even numbers in the list, then the median would be some sort of a number in the middle of two numbers. So if there are 10 numbers, and so yeah, numbers add the 5th and the 6th number together and divide the result by 2, and then you will get the median. Okay, so that's how the median location is found. So binary search works in a specific way, where it will first find the median item which is already there, and then it will search in a recursion way, where it will search for the higher number or the lower number. හරි. ඕක තේරෙන සිංහලෙන් කියන තේරෙන විදිහට කියනවා නම් to explain this in very simple way. Let's say you first sort the list. Right? So let's say you have numbers starting from 1 to 100, and you are trying to search for number position, let's say 30, 32. Okay, so then now if you take the linear approach, sorry, let's say you are searching for the number 71. Okay, then if you take the linear approach, what will happen is it will start from 0 to 79, and when it reaches the 79th position, that means a recursion happens. So it goes through recursively, loop එකක් ඇතුලේ recursively it goes through and finds the 70, let's say 71, the 71st position, and then it will say, hey, I found you and this is where it is. So it goes through 71 times, right? But here what it does is, this basically gets the list, sort it first, and then you get the median amount, and you find out whether what you're searching is equals or higher or less than the median point. So now, since we are looking for 71, that means if this is a number set of 0 to 100, that means when you take the median, you can easily find out we are looking for something greater than the median, right? So 71 is greater than the median point. So that means if the median is here, we take, so if the median is too high, then repeat with first and 2 with the sub list on the left. If the median is low, then repeat the first and second steps when the maker. So you again find the median and you divide it and search. So let's say we have a number set of numbers let's say we have 13 numbers, right? So if you have 13 numbers, then the 7th number number 7 is the median, right? So now you are looking for, let's say you are looking for number 9. So what happens is this first starts, it gets the 13 numbers and then divide it from the center. It takes the median, so the median is 7, and you check if the search number is greater than or less than the median. So obviously the search number is greater than the median. We are looking for 9. Then that small part is kicked out. You don't have to check that, right? The beginning part is kicked out. Then what you do, so then since that is greater than, so that is greater than the median, current median, so then what you do is you get that portion and again look for the median of that portion and then check if the value is greater than or equals to that median, right? Then what do you get? Again you get 7 numbers, so you will get the median, and here when you get the median, what you do is again you check. So in that case the value would be onto your left hand side, right? So likewise when you divide it one by one, it's easy to find out. So that's a simple example. Let's jump into a working example and you can check. So in this list we are looking for number 13. Okay, now here see these are the numbers which is there in the list, right? So here what you do is from this set of numbers you select the median. So the median is technically 31, right? Not මෙතන මේ median කියන්නේ මේ don't get this mixed up. මේ මෙතන තියෙන number length එකකින් median, not the actual numbers. So what we do is we get the median number out of this. Okay, so now when you get the median number, what you get is 3, 13, 24 and 27, right? So now we are looking for 13. So as this is too high, the sublist to the left of the median must be searched. Then 32 එන්නේ අපි හොයන්නේ 13නේ. We got 31, we are looking for 13. So that means this particular part has to be searched. When you are searching this part, then what you do is again you find the median. So the median number of this sublist is now again selected. So in this case we get it as 24 because it's started for 24. So here again we check whether this is too high or too low. So this is again too high and the sub list to the left must be searched. හරි. ඉතින් මේක ආයි ගත්තා මේ ටික අයින් කරා. හරි. Then you jump to the sub list on the left again. So sub list on the left in this part you can now you check for the median. So median is basically the number which we are looking for, number 13, right? So technically to search 13 we just went through 3 passes, 3 recursions, right? 1 to start off, second and third. Okay, so in this example you can see it looked 3 attempts. It basically went through 3 attempts to find the search item, and it just gave you the search results. But if you done this using a linear search, then it would have taken a long time, right? Because it would have gone through the entire list of items, and let's say if you do a search recursive, then that would take a very long time to find the particular number, right? So that's the idea behind this whole concept. Okay, so I hope the binary search is clear. Do you have any questions? We'll do a lot of practicals on this. We need to write some methods and try this out. So for
That's the question I had.
yeah, sure, shoot.
Are there any Java like factors online?
Java?
The Java script practicals.
JavaScript practicals. JavaScript practicals. Yes. the best would be to use the JavaScript trainings on W3 schools. So go to W3 schools, and in W3 schools you have JavaScript, and there you can actually you can get lot of different practicals. Let me show you quickly about what I'm saying. What I'm talking about. Cool. Hold on. So you can go to w3schools.com and click on JavaScript here on the main menu item, and then you will get a full JavaScript tutorial. So here I think this would be the most easiest place to learn, because the fun thing is it gives you the online editors so whatever you write or test, you can literally test it. Example is now JavaScript arrays, quite fascinating and easy thing to try out. So let's say if you want to try out these arrays, you can actually click on try it yourself, and you get an array tutorial. So let me increase the size of this a little bit. See, you have the tutorial, and the fun part is you can actually you can literally update this code and try few things out. Okay, now if I go back, if I click on run, I just added a text as hello. So if I click on run, you should be able to see the update. Okay, so this way it's actually quite easy. So you can easily try things out. Hope it's clear.
Yes, sir. So like in school, we are not doing like Java, we are doing like Python. I'm just asking.
Okay, you're doing, yeah, I will be also following Python, but you said Java or JavaScript?
Java.
Okay, Java also you have it here. So you have the Java tutorial. You can actually go through this. It's so I believe W3 schools would actually give you the foundational knowledge of Java easily. Yeah? It's quite straightforward. You can easily go through this and get a full idea about the Java foundations and how it works, because you have different exercises. You can submit answers and you can try this out. Also, you have certificates. Okay, so if you do this basically, you have this Java exam certificate course. See, it's just it's about $95. It's about 30,000 close to, but you can actually get this certification as well. So that will basically make sure that you have a particular certification, making sure that showing off that you know Java. Okay, you can try that out. So they have like most of the companies, they do trust this company as well. Okay, I hope that gave you an idea. But from my personal point of view, I think Java and Python and C#.net and PHP and JavaScript. So all these go hand in hand. So if you are planning to get into the IT industry, learning Python would be perfect, because nowadays we do have a lot of Python vacancies going on. Plus Java is also perfectly fine, because we have a lot of companies here in Colombo, like companies like IFS, who looks for Java developers and basically have Java vacancies, as well as Virtusa, Creative Solutions. There's a lot of companies like doesn't ring a bell about all the companies, but yes, there are a lot of companies, as well as again there's a massive demand for open source developers based on PHP and JavaScript, like frameworks like React Native, Angular, and Vue.js. There's a massive demand for them. So just keep that in mind as well. Okay, so yes, hold on. Perfect. Okay. So quickly we'll just cover this part of about the efficiency. So yeah, so the efficiency is as we discussed in the previous page, the efficiency is mostly focused on the number of memory points which that's going to use. So the linear search was more efficient because it only had to carry out 2 comparisons instead of the 3 for the binary search. But the problem is, if we have a lot of data points, then that's not going to be efficient because that will take much more power. Okay, so this power is actually the most complicated point when it comes to software engineering, because the more it consumes, the more power it consumes to process your code, is that will automatically take the quality of your code and the quality of your product. Because if your product needs a massive lot of let's say CPU power to process and run the system, then that would actually that won't be a good approach, because then it will cost you a lot. Okay, so that's why we use custom popular systems, as well as also that's one of the reasons we do not write these type of algorithms and systems manually. Example is if you want to sort a data set, now we will be like 99.9% of the time we don't write these sorting algorithms by manually. I mean, like not like you don't write it as a manual code. So what you do is you write it using some sort of a plugin or a wrapper which is already inbuilt in the system. Example is now in Java, if you want to sort an array, there are a massive lot of array sorting algorithms, tools and code plugins which you can import the plugin and you can use that plugin. So those plugins have optimized their method of processing so that it will automatically reduce the number of usage or the CPU usage drastically, so that you can make sure that your system is performing properly. Okay, so decomposition. So that's about for the searching and algorithms. Sorting and searching algorithms. Now we jump into the last part where we talk about decomposition and abstraction. Okay, so here, give 1 second. Yeah, yes, perfect. Yeah, decomposition and I was just going to check the questions. Okay, so prashna. So decomposition and abstraction is basically the process of splitting things up and coming up with a particular set of sub problems. Okay, so all of these are problems. Okay, now example is when you analyze about a particular task. Okay, you can actually watch the first video which we the first or the second class we did. There I actually showed a video about how to make a peanut butter sandwich. Okay, I think you all might have watched it now. So in that video, it's actually not an easy thing to make a peanut butter sandwich. Okay, I know it's quite simple. You get peanut butter, api peanut butter ingala api jam kiyamuko jam sandwich එක. When it comes to the process wise, it's quite easy. You just take some bread, පාම්පෙත්තක් ගන්නවා, you take some jam and butter or margarine and you apply it, you put the jam or margarine and you get another piece of bread and you create a sandwich. Simple as that. But there are multiple different points which is not visible to you. Okay. Now, if you take the same problem, now there are some underlying problems where you have to first understand before you start working on this. Okay, so I will explain the same concept with the peanut butter sandwich part. So let's say to start off with, we get the let's rephrase this. Peanut butter අයින් කරලා අපි දාමු නිකන් jam පාන් කනවා කියන. Okay, so you get some jam and you need to create a sandwich with jam and margarine or jam and butter, right? So how do you do that? You first need to find bread, right? So what's the problem now? You have a problem. You are hungry. Okay. So the primary problem is that no, you are hungry. So you need food. What do you want as food is something which you now finalize that you want to have a jam and bread sandwich, right? Okay. Now, then you have to investigate the requirements. Okay, I'm not saying you to investigate why you're hungry. Yes, you're hungry when you feel hungry. Yes, you need to eat, right? There's nothing to investigate in that. But again, but then again, now we have to analyze the problem. Hari, now I need to find what? First of all, you need bread, right? So where do we have bread? Have your parents bought bread yesterday? Or is there any bread in the fridge? If it is in the fridge, then what to do? It should be cold, no? Do you take a pan out and put it on the gas stove and try to toast the bread? Or you put it inside an air fryer? Or you put it inside the microwave, right? So how do you process it? And then, okay, I'm just telling you how you can expand a problem. Okay, so that's about the bread. Now, if by any chance you don't have any bread at home, then what to do? Now, are you looking out for an alternative? Biscuit kanada. Okay, if you are looking for an alternative, then let's say what do you call this biscuit? This cream crackers. Okay, so let's say are you going forward with cream crackers? If yes, do you have cream crackers at home? If no, then what to do? So then now you don't have bread and you don't have cream crackers. So then you'll have to opt in for a different option, right? Either you have to forget about the whole thing or you have to think about eating something else. Right? So likewise, those are the problems. Now then, that's about the bread problem. Okay, let's say if everything checks out, yes, you go to the kitchen and either you ask your mom or your father, or you can see some bread lying on the kitchen table. Perfect. Bread is done. Then the next option, jam. On the problem sticker. So, do we have jam? Fridge checker. So, where do you normally keep jam at your house? It can be either inside the fridge, or it can be on top of a table, or it can be inside some sort of a cabinet or a cupboard, right? So first you have to find the jam. Okay, you have jam. Now, is that the correct flavor you want? Or are you looking for something else? Do you have different types of jam at your home? Right? Onna prashna. Hari. Okay, now you found the jam. Now, does that bottle has enough jam? Let's say your brother or your sister, one of your siblings have finish the bottle. Then that's again another problem, right? If that's the case, if you don't have jam, then what's the second option? Are we going for another different alternative? Hari jam, then I'm just going to have some bread and butter. Okay, then okay, that. Okay, so if you take the good path, if the jam is there as well as jam quantity is also there, and the jam you like, the type of jam you like, it's also there, then perfect. Then we can say that's true. Then butter, same process, right? You don't keep butter inside a cabinet or a kitchen shelf, no, so obviously you will be keeping it inside the fridge. So you go to the fridge, you open the fridge, you check if butter is there. Yes, butter is there. But does it have enough quantity? Yes or no? Yes, if it has quantity, okay. And do we have different types of butter? Because some households we have like garlic butter and unsalted butter, salted butter, and so on and so forth, right? There are multiple different types of butter or margarine. Flora, the Anchor, the Astra, they're likewise, right? So all these things are different problems, right? And these goes into sub problems as well, right? So if everything acts off properly, then ultimately at the end you would be able to make your jam and butter sandwich, right? Okay, so that's the process how it works. So now what did we did? So I just explained it right as it is, but what we did was we actually analyzed the flow of making some jam and butter sandwiches, right? So like the points you have to analyze, the points you have to check. So that's the exact thing about investigating the requirements. Okay, so when it comes to the design of a solution, you must investigate all the requirements which is required for that particular solution. So that's what we call as designing. Okay, and then when you investigate the problem, now we have to decompose it. Okay, so let's jump in, and so now I gave you guys an idea about how this investigation works. Now let's jump in and see what is decomposition and how we can use these investigated items into solving problems. Okay, so problem solving part. So now here we have again 3 subject vocabularies. Okay, so this is something which you guys also must keep in mind. So primarily we have the computational thinking. Okay, so give 1 second. Yeah, we have the computational thinking. So the computational thinking is the thought process which you have to go through to give a solution based on how it can be continued or carried out by a computer. Okay, so remember to highlight this part. It's really important, these keywords. So computational thinking. Okay, now let's say I'll explain this in a very simple manner. So let's say if we take the same example of making this jam sandwich. Now let's say if you are creating a robot to make a sandwich, then it works in a different way, right? Because you have to have a specific mindset and a computational way of thinking to write that set of actions. So let's say now for you have, now you guys are teenagers, so you have experienced your childhood and you know what type of what jam looks like and how to get some jam from a bottle and how to apply it on a piece of bread, right? And how to find the proper side of a bread and how to know if the bread is good or bad. The bread can be old and it can be bad, right? So all these are sub factors. And now for you, as I explained during our previous class as well, for you have that in your brain or in your memory. So you know that process. But when it comes to a computer doesn't know anything, right? So unless you use some sort of AI bot, that's a whole different story when it comes to AI and language models and all. But if just think you're just creating a simple computer program, then the program doesn't have any consciousness, right? So without a consciousness, you have to be precise. So that's why we say computational thinking is basically the method which must be represented in the form that a computer can effectively understand. Okay, so the second word is so that is computational thinking, and the second word is decomposition. So decomposition is breaking a problem down into small or manageable parts which are easy to solve. Okay, now we are going to jump in decomposition. So just remember the point. So we just break it into small parts. And then there's another another word called abstraction. So abstraction, okay. So the abstraction is the process of removing or hiding unnecessary details, okay, so that only the important ones are remaining, or only the important ones remain. Hiding means now there can be multiple different specific data points which you don't oftenly use, or you use it but you don't have to expose, right? So if that type of a situation, you use abstraction. We'll go through it, don't worry. Let's jump in and see. Okay, so let's start with decomposition. So yes, so this is a simple example. Okay, so basically as you can see, as you can read, so the decomposition is usually the steps of solving a problem step by step. Okay, so back, if you go back to the jam example, decomposing that particular thing is basically like making sure that you split that process into parts, right? So you split it into different problems, all the problems I said before, and then you manage and go through the problems one by one. So here we have an example. This is about a tic-tac-toe game. Up here, tick 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 gala binduwa දාන එක. හරි. So here you play against the computer, right? So in this north and cross game, tic-tac-toe, this is how it works, right? So basically you need to first, so this is your problem, this is your primary problem, right? So you need to create this game, simple as that. So for that, what do you need? You have to first understand, so in order for us to create the game, in order for us to come up with the game concept, we have 4 primary problems, okay? So the 4 primary problems, these 4 are the main problems we have into like getting the basic system up and running. So what are these? First of all, we need a design and a user interface, right? So like, okay, so you have seen games, and when it comes to these games, there are the primary component of a game is the user interface, right? What or how you interact with what you do or interact, how the way you interact with the game. So that's the primary method. Then how to keep track which squares have been selected either by x or 0. tic-tac-toe දන්නනේ අපි x එකයි බිඳුවයි ගහන game එක x we just create a small 3x3 grid and we cut it off, no? So for that, then the second option is how to keep track of which squares have been selected by x and 0. So there has to be some sort of a method of keeping that selected, right? Then the hard point, the fourth item is to make sure to come up with a way of how the computer will decide which square to select, how the computer can decide which particular square it has to select in order for it to play the game, right? So we have got the three major points, and now finally we got the last point, which is to know how the computer will decide when the game is over and who has won, right? So that is also then that is also a problem, because now we need to find out how the computer the computer actually needs to know how you won the game, right? Or whether you have won it or whether you have lost it. Okay, so now this is a simple high level set of definitions. Right? So now after this, then what we need to do is we need to break this down into multiple sub problems. So now we know the main requirements. Now in the software industry, we call this the main requirements. Okay, let's say if I'm the customer, as the customer, I will say something like this. මං කියනවා කාටරි මට tic-tac-toe game එකක් හදලා දෙන්න. Okay, that's the requirement which comes from me as the customer. Okay, now let's say if Daham is the developer, or if you are the person who is going to work on this, then for you will first break these points down. So these are the requirements which you have understood that it's required by you. So now then what we do is then you have to come up with the subtasks. So this abstraction is, so that's the idea behind the decomposition. Okay, so now this is, be careful, don't get this mixed up. So this is just a explanation, but decomposition goes into multiple levels. So after that, once you get into this has to be decomposed into another part. Okay, so keep that in mind. So then the next point is abstraction. Abstraction is something different, where we use this basically all the time, and every place we almost live in. So let's say okay, so let's say simple example like a abstraction. So now okay, so api make again may, if you take news, okay, so if you get this live at 8 or this Sirasa news and all, so they actually give you a abstract view before the news broadcast goes on, right? So the news goes at 8 o'clock, but around 7 o'clock they say today's news, and they put a 5-minute abstract view of all the news, where they say they will just tell you the kind of like the basic things. They won't say tell you the full story, but they will actually take out all the essential things and the fun parts or the interesting things from the news, and then they will do another video. So obviously when you look at it, you will be enticed to watch the news at the end, right? So example here, this basically gives an example. So somebody might say, I was walking down the street when I saw a cat. Okay, you immediately understand what they mean by the street. Likewise, so that's also something. Now, let's say somebody talks about something which happened at Golf Face. Okay, so now everybody knows what is Golf Face is, right? If you live in Sri Lanka, and ideally if you have gone out, or if you haven't been living under a rock, obviously yes, you know what in Sri Lanka, Colombo and Golf Face, the terms you might have heard at some point. So that means now I'm not, so if I'm going to tell you something which happened in golf phase, I would just say, okay, there was a party, there was a massive event at golf phase. That's it. I won't need to exactly tell you where golf phase is and so forth. Right? Now that's the point behind abstraction. I hope it's clear. Daham, it's okay, right? Clear, right?
Yes, sir.
All good? Okay. So when I tell you that, it will basically allow you to imagine and understand some sort of a particular party or an event which happened in golf phase. So when it comes to this abstraction, guys, the primary point is you don't have to export the details or tell the details out. You can just keep it as it is and only allow other users to basically use the specific details which they need, so then they can start. So I'll tell you a example when when it comes to actual programming. Now inside in programming languages, we use abstraction up to a certain extent. Okay, so what we do is we basically use this when we are building libraries and different types of platforms. Okay, so let's say if I'm working on a Java or a Python plugin, okay, then I would basically create something called an abstraction layer. Okay, so this abstraction layer, what it will do is it will create a wrapper so that you will be able to see and interact with the system without technically knowing what is going behind the scenes. So example is we have this libraries and plugins. Okay, if you take Google has a massive lot of plugins which you can use. Example is Google Maps, Google Translate, and Google Gemini, and OpenAI has ChatGPT, and now this new kid in the town called DeepSeek. They also have their APIs, and all these things mix up in together, right? So all of them gives you a specific library of content which you can use to consume their services. Okay, now let's say if you want to add Google Maps into your website or into your application, let's say you are building something like a taxi hailing app, something like Pick Me or Uber, then obviously the easiest way will be, not the easiest way, the only possible available way for you to have a full map, including reservations and a calendar and all these navigations and everything, is by using Google, right? That's one of the services which is available. So if that's the case, then you don't need to let's say, then when you want to implement it, let's say if Google asks you to learn the entire way, all the systems of Google Maps in order to do a simple small thing, it's not going to work out. No? You will be like completely off when it comes to learning that. When you have to learn the entire method, how it works now, so it's not going to be practical. Now what they do is they give you an abstract layer to utilize their services. So simple as that. All you need to do is just import Google Maps, and they have this API documentation. API means in short form application programmable or program interface. Okay, so they have this API documentation which tells you how to implement and use their services. So in simple terms, using the API documentation, you can use the abstract layer to use the Google Maps, because ultimately what you want is to have your application to show where your driver and your rider is, right? Sorry, driver and the rider is, right? Apart from that, I don't think you need any sort of a Google Map for anything, right? So that's an example in real life. So other way around, let's say if we take this worked example in the book, so here it says Yasmin is designing a computer version of a game in which users have to throw a die to find out their number of moves. Okay, so in the computer game, users can't have an actual die, so she will have to design a pretender virtual die that behaves the exact way. Okay, so now in this case, Yasmin will have to use her powers of abstraction to abstraction to work out the essential features of the die and represent them into the computer code, right? So we have to find out the main essential features, and then this can be actually a model of a real life event. So I think this is what I told you about Google Maps is much more clear than what they were calling. But then again, on top of this, so we do have the modeling part. So what it does is it basically allows you to create a model of a real life event or a data set. Okay, so now I'll explain what is a model in a while, but first of all, let's understand one last point about the number of the levels of abstraction. Okay, now there are different levels, or let's say types of abstractions. Okay, so the higher level of abstraction, the less details which is required, and at the same time we use abstraction in all things almost every day, right? So when it comes to very simple command like print, okay, now when you use print, so this is the same thing which I told you guys about the Google Maps. Now let's say if we are trying to print something to the console or to the command line, in Python we use the print command, right? So print command or the console command, and when this is being used, ideally you don't need to learn how it works behind the scenes, right? Now let's say you want to print something into the console, saying like when a user is logged in, you want to show hi, and you just need to send a message. Technically that's enough, right? You don't need to go more than that, and you don't need to learn more than that as well, because you are focusing on the specific action. So likewise, you are not bothered to know about all the details how it can be accomplished, but the thing is, now it just need to work. So that means you are basically using a high level abstraction which the underlying layer is completely hidden for you. So let's say if we take this example, a driver tuning the ignition of the ignition key to start, turning the ignition key to start a car does not have to understand how the engine works, right? So if you get into a car and press the start button or turn the ignition key, again, you don't have to think about how the car works. අපේ පාරෙන්න මිනිස්සු 90% ගත්තොත් they don't know how cars work, no? Even I don't know how I know how an engine works, that's a different story. But then again, if you show me a car and ask me tell me how that works, I will be like completely out. So I won't be able to tell you exactly how it works. So, but the thing is, if you show me a car and ask me, so can you drive this? I will be like, yeah, okay, why not? So you can just get in and we can drive any car. So that's the point of way of abstraction as well. Okay, so examples. So now this tic-tac-toe game. So now there we basically talked about few methods. Now here we talked about the inputs and outputs and how the game is going to interact with each other. Okay, so now we'll go through this and see how it works. So the computer, obviously the computer will go first. So it can be the user. So but here in this case, let's say the computer goes first and then the user, and this continue until either one wins or all the squares have been used. Okay, so immediately a pattern can be recognized, right? Because you go first, or the computer go first, and then you go second. Then the computer goes again, and you go again after that, right? Likewise. So here you get the inputs and outputs. So now, what type of inputs do we need? So first of all, we need to start the game. Then we get the entries for the user, and here you select a new game and finish. So start the game, entries for the user, what type of entries you are going to put, and you select a new game and you finish it, right? So the following outputs, so those are the inputs, right? And then we need to have the outputs. So the outputs would be something different. So there can be messages. So a message must be sent to inform the user when it's their turn, and there also has to be a message sent to inform the user if they try to select a square that has been already used. You can basically, so you get the turn, so you must get a message, okay, now it's your turn, where you will be using your whatever the cursor or the device, or let's say if it's a mobile app, the touch to basically highlight a square, right? At the same time, you should not be able to touch or click on a square which already has a x or a 0, right? So now let's say if I'm using x and you're using 0. So if I have already crossed this square, that means the square is already taken, right? So then all you have availability is about the rest of the squares like this, right? So if I am already using this one, then these two, if you haven't used this, then you should not be able to put anything here, but you should be able to put something here and here. Okay, so let's say if you put it here, then I am not able to use this square. Since I have already used this and this is your one, I'll be able to use the rest of the squares. Okay, so I can put one here, or one here. Okay, so that's how the actions should work. So then when that is locked, then it's all good. Then we need another set of outputs, right? So there has to be a message where it will inform the user if the game is a draw, right? That also has to be a message. And a message to inform the user that if they won or the computer won. Okay, so it will be two messages, either one message saying that they won, or another message saying the computer won, and a message to ask the user if they want to play another game or they want to finish. It should ask whether you want to continue also. So that's the next point, right? So when that is done, then we understood all the required actions, right? So these actions are now sorted out. Now we know these are the particular set of actions which is technically going to be the input and which is going to be the output. Now the process. Now we need to follow the processing and understand what are the points which is need to process. Okay, so again this is again going into an abstraction layer where we try to understand the specific points of things which you need to process. Okay, so first of all, set up the grid with the 9 squares. We have to set up a grid, right? Then we need to initialize all the variables to a start value. Variable should have a start value, right? Then we have to decide which square the computer will select. So there has to be a specific square which the computer will have to will be selecting, right? And then allow the user to select a square, because so we need to decide and find out what are the squares the computer is going to select, and after that we have to allow the user to select a square also, no? So then the user will be selecting a square and check, and after all this done, we check if the user has already selected and check if the user has selected an already used square. This is the one which I just explained a couple of seconds ago, where you should not be able to click on something or some sort of a square which is already selected, right? So then that has to be checked as well, and then check if the computer or user has won. Somebody needs to win the thing also. So either one of these angles should be validated, and if the computer has won the game, then you have to send a message. But at the same time, there can be a draw as well, right? So check if all the squares have been used and the game is a draw. Then you should get a message saying the game is a draw, and then we are basically done. Then whether we can ask whether you want to restart the game, right? Or there has to be another process initialization where you have to allow the user to select a new game or finish. Okay, so that means the game has to start, and the game needs to have some sort of a process of ending it, right? So see how complicated this is, right? So this is why now in grade 8 we learn about creating storyboards and program structures. I hope you guys have done that if you have followed the Inspire Computing book. So there we talk about how to create program structures and these presentations with particular storyboards. So the reason we learned that during in the previous grades is to support this particular concept. So when you are building some sort of an application, or it can be a software or any sort of app, you need to make sure that these steps are being followed exactly, because first you need to follow the steps and then only you start coding this. Okay, now here, so that's the base idea behind this. So now when you look at this in a way, this solution is still at a very high level of abstraction, right? And the details, like obviously we need to add a massive lot of more details to this, right? For example, let's say if a program is going to work on this, the programmer must decide on how the game will record the details, which player has selected which square, and how the game will decide how it works, and who won, and how the game will decide if the computer has won, and the programmer will have to go through a massive lot of move details, like to find out and control which how that movement worked. So how you clicked on some place, and design different UI algorithms, different flows, and ultimately the programmer must be able to create a design algorithm for this as well. I mean a program algorithm which will basically let him code it at the last moment. So then you might be using something like a programming language like Python or Java or JavaScript, or you can just use HTML and simple JavaScript as well. And depending on the selection of this programming language, you'll have to find and plan how the content is going to be displayed and how this content is going to support your system, right? So all sorts of these validations has to be done at a certain point, right? And the details has to be basically written down. Okay, so now we understood now we went through the basic or the steps about the decomposition and understanding the list of items which is needed to be done. Now we jump into the last step about how we are going to code this. So whatever said and done, how complex algorithms you build, at the end of the day, it has to be developed, right? So you need to use some sort of a coding mechanism or a coding language to create this program, right? So now for that, we use programming languages, okay? So now in this case, we have like, so you guys, for IGCSEs, we do not go into low-level programming languages such as like C or instruction type of programming. So we are only going to stick with high-level programming languages. So we will be learning Python and Java and all these type of languages because it's actually easy, right? But now there's a point. Now you are given the easy path out by using a programming language and a high level programming language. So it's basically easy for you to write the code, right? But there is a point because now your CPU or your device, it technically cannot read and understand a high level programming language, right? So a high level programming language obviously has to be converted into a low level programming code, right? Because example is whatever the language you use, ultimately your CPU can only understand ones and zeros, right? So that means you have to convert it into a low level language. So for this we do use translation layers. So we call them translators, okay? So these are like code translators which they will translate. Now even if you have used Java or C Sharp, .NET, you know that the code has to be compiled, right? So once you do some sort of a code change, you have to save it, and then in order for you to run the code, you have to compile the code. So when the code is compiled, then it will create a binary code which can be understood by the CPU. Okay, so then the CPU will understand that code and it will start running the code. So now these languages, we also call them, so these languages are therefore basically known as working at a high level of abstraction. So very far removed from the actual language of a computer, because they are working in a very high level abstract layer, so that it will basically make your life easier. Okay, so now when it comes to processing, there are multiple parts. Now since for this tic-tac-toe game, කොටු අපි සිංහලෙන් කියන කොටු කපන game එක කියලා, that game could be built on separate algorithms, right? So there are a few points. Now first of all, you have to decide where the computer should make its selection, right? So now in this case it can be the computer entry, and again checking if the computer or the player has won, so it could be called check if won. And the third one is checking if there's any other empty squares left, so this could be called check draw, right? Because somebody needs to check if there are any items left, right? Okay, so this can be three different separate algorithms which we will have to write. And then since these are not separate algorithms, it's just single algorithms, but then again these algorithms could be used whenever they are needed, because it will be working in a recursive manner, right? Because algorithm part by part user known. We will have to check every time whether the user won the game, every time whether the computer won the game, or every time if the game is a draw, and so on and so forth, right? So there will be separate algorithms that will be used. Okay, so now for that part, that is where we end up by jumping into the concept called the subprogram. Okay, so subprograms, give me 1 second. Um, yeah, yes, yeah, we are at the end of this part. So, yes, so the subprogram is what we will be basically jumping into in the second unit. Okay, so the subprogram, we'll just check the vocabulary. So this is where now things get interesting, because now we'll be jumping into coding, and we'll see how this works. So subprograms, or we call them subroutines as well, is basically the vocabulary. Okay, so they are self-contained modules which perform specific tasks which can be called by the main program whenever it is needed. Okay, so now let's say if some informations are getting repeatedly added, then you can use this one of the sub programs to basically help you do that. Okay, now now let's see. So yeah, so we do have a small activity where we need to come up with a quiz game, as well as we have some activities, and we have few unit questions. Okay, so I okay, so I'm going to give some homework first of all. So you can either submit it through the LMS, or you can actually send it directly through WhatsApp to me. So both options are available. So I want you guys to go through this unit questions, and let me know. Like, you can just write the answers and send me the answers. So you can go through this, and don't search the answers online, please, because yes, the answers are available online, but you guys have to write this, and just work on the questions, please. And here what you can see is, when you are going through this, you can see on the side of the thing, you have the skills and the area of expertise which is being required for you to learn. Okay, so when you go through this, it will basically give you a clear idea what it is. So next week I will be starting the class by going through these questions, and then we will be jumping into the second unit. Okay, so we'll be jumping into programming. So just to give you a quick brief about the programming code, we will be starting from developing code. So we will be using Python in this case, but if you guys want to or like to learn in Java and C Sharp also, let me know. I think it will be easy for me to show in Java. I can show C Sharp as well, but I'll show you guys few tips and tricks on how to get it done online, so that you don't have to set up all these platforms on your PCs. Okay, because setting it up is actually a bit of a hassle. Okay, so then next week, from starting from the next class, we'll completely jump into programming, and I will be uploading another video, guys. I will share this. So so in that video, I will explain how to set up the Google Colab Python platform. So I already explained it up to a certain extent during our previous class, where I showed you guys how to set it up. But I will do another dedicated video for that only, and will put it online in my channel, and we'll share the link with you. And probably you once that link is once that video is on, you will find that link under the description of this video as well. So using that, please do go through it, and I want you guys to be ready with the Google Colab, so that we can start coding from the starting of next class. Okay, super. So that would be a conclusion for today's class. And Daham, any questions?
No, sir.
All good?
Yes, sir.
Okay, I'm going to ask you a question. How did you guys did Python? Did you install it on your laptop?
Like, sir, because like we they have it installed on their.
Ah, okay. School PCs.
Yes, sir.
Okay, but how did you practice it at home?
So I have the application with me.
You have the app. Okay, okay. So have you tried out Google Colab?
No, sir.
Perfect. Okay. So I am currently doing a video, so I'll upload it somewhere by Monday, and we'll share the link on the chat as well. So go through that, because using Colab, you don't have to install anything on your machine. You can just try out Python code as much as possible, and you can try some AI stuff as well if you are interested. Okay. So that way it's actually that way it makes things easier to develop. Super. So please do go through that, and I really appreciate if you can do that unit work and send it to me, so that we can go through it next week and check the questions. Hari, okay, perfect. So then, thanks. Let's catch back next week.
Okay.
Okay then. See you. See you. Bye.
Is it?
See you. Bye.